Okay, so 0 is not an option in the denominator. And so the first thing that you do, because you're going to have, this is the way you're going to check your answers, is you're first going to tell me what makes the denominator 0. We're going to set our denominators equal to 0 to determine what that is. Now, sometimes you can look at these. What's going to make this denominator 0? These are the values that x cannot equal. We want to keep track of these. We want to be able to locate them easily. So we know x can't equal 0 because of this denominator, right? What makes this denominator 0? All right. So if our solution says that x equals 7 or x equals 0, those will be extraneous solutions. Does that make sense? Okay. All right. So I'm going to have a couple of options. I will have a simple proportion. In other words, a fraction equal to a fraction. And if that's the case, the easiest way to solve this is to cross multiply. That tells me that 3 is going to be multiplied by, and set that equal to 2 times 5x. That gives me then a solve. 3x minus 21 is equal to, so negative 21 is equal to, and that means x is equal to. Okay, this solution, the way we check, cannot exist here. The things that x can't be are 0 and 7. What did we get when we solved? Negative 3. Is this an okay solution then? Absolutely, we're good to go. So we start out easy and we get harder. Okay, what are the values that x can't equal? That's the first step that you always have to start with. 3 and negative 3. If I plug in 0 down here, what do I get? 3. And if I plug in 0 over here, I get negative 3. Exactly. What values make my denominator 0? Okay. All right. Emily, be better just to start with this example right here. Okay. All right. So what am I going to do now? Well, I got to sneeze. So I'm going to say negative 4 times and 5 times. And don't forget that negative. That means negative 4x plus 12 equals 5x. Correct. Solving gives me 9x is equal to negative, which means x is equal to negative 1/3. Does this value exist in what x cannot equal? So is this an okay solution? Absolutely. Because it's what makes your denominator 0. So here it was, if I have 5, so you're going to kind of like make a little 5x equals 0, so x equals 0. X minus 7 equals 0, so x equals 7, and those are the values that they can't equal. It's like you set up a little mini equations with your denominators, Emily. Does that make sense? Okay, is this a problem that I can cross multiply with? I have an addition. I have 2 fractions on one side. If I cross multiply, it's fraction equals fraction. Okay? So even if I move one of these fractions to the other side, it's not really going to make it much easier. Yes? But if we're going to add them together, we have to get a common denominator. First thing that we do is figure out what makes my denominator 0. Do I care about this first fraction? Because do I have a variable in that denominator? So who cares about that denominator? Well, what about this one? X cannot equal 0. Okay? So we're going to say, so we're going to do a little sidebar. We're going to say 7 over 2 plus 3 over x. What's my common denominator? So that's going to be 7x plus all over, and that's going to equal what? But we're going to make that a fraction, aren't we? 3 over 1, because we want to try and be able to cross multiply. So here we have 7x plus 6 equals 3 times 2x, which is 6x. And so what is x going to equal? Negative 6. Is that a value that x cannot equal? It's good. We're all good. Then it's not. Then we can't use that as a value. It would be no solution. Yeah. Okay. All right. Here we go. This one's a little bit more confusing. And at some point, we want to not get a common denominator. Although we still want to think of what our common denominator is. Okay, so look up here. I said, if not a simple proportion, figure out what the common denominator would be and multiply through to get rid of the denominator. What you multiply one side of my equation by, I must multiply the other side to keep it in balance, right? So, we're going to do that on this one. What can't x equal? That's the only thing that it can't equal, right? It's going to be on Moodle, okay? All right. So, look at all three of your denominators. If I wanted to multiply by something to eliminate them, or if you want to think about if I wanted to get a common denominator, what would my common denominator be? 2 times x minus 1, right? Are you comfortable with that? So look what happens when I multiply 2 times x minus 1. We're going to put that over 1. And I'm going to take 3 over 2 plus 4 over x minus 1 equals x plus 1 over x minus 1. When I take this mess to my first term, what's going to drop out? The 2's, right? So I'm going to be left with what? 3 times x minus 1. Let's do it like that. We will multiply it out, okay? When I take this mess, because I got to do it to every term, right? On both sides of my equal sign, correct? So I'm going to be left with what's going to cancel out? And so I'm going to be left with 4 times 2, right? See how we're losing our denominators, which is really a nice thing to do? And when I take this to my last term after the equal sign, what am I left with? And now what I have is a very simple equation that I can go through and solve easily without having to worry about denominators. And so I'm left with 3x minus 3 plus 8 equals 2x plus 2, which is going to tell me that's 3x plus 5 equals 2x plus 2. X is equal to negative 3. Is this a value that's allowed? Because it's not 1. It just would take a long and be a lot harder. So when you don't have a simple fraction equal to a fraction, proportions, the best way to approach the problem is to figure out what is my common denominator, and now let's use that to get rid of all the denominators by multiplying each of the terms by that value. Does that make sense? Okay. Look at the next one. So what can't x equal? Here it can't equal what? Negative 1 here, and here they're the same, so what can't x equal? Correct. Okay. What's your common denominator? Do I need to do 2x times 2x, or can I just do 2x once? Because it doesn't appear twice in one denominator, right? It does not appear twice in one denominator, so I just have to use it one time. So I'm going to take 2x times x plus 1. I'm going to put it over 1. And then I'm going to multiply that by 3x over x plus 1 minus, we're going to have to worry about that negative sign. Okay? 5 over 2x equals 3 over 2x. So when I take it to my first term, what's going to cancel? And so I'll be left with 2x times 3x. When I take this to my second term, I'm going to have minus 5, and then what's left? Are y'all with me on this? Stop me if you've got a question. When I take this mess to my last term, after the equal sign, I'm having 3 times what? Y'all good? And so I get here, first term becomes what? 6x squared, good, minus what? Minus 5 equals 3x plus 3. So the number we're solving, so yeah, there needs to be an equal sign here. So this says x minus 5 equals 3x plus 3. X equals, 2x equals negative, oh, there's an x squared. I missed out on this, my bad, sorry. Yeah. My arrow, I didn't see that. So I'm going to get 6x squared minus 8x minus 8 equals 0. Would you agree? Yes.
Why is that a negative?
How do I move the 3x to the left? I can divide everything by 2, can't I? And I can divide it by 2 because it's set equal to 0, right? So it's just going to disappear. Would you agree? Right? Right? I can, but I'm going to want to get rid of it. Then I'll divide it. So I've got 3x squared minus 4x minus 4 equals 0. Do our little boxy thing. 3x squared, negative 4. Factors of negative 12 that give me negative 4 are 6, negative 6, and positive 2. So I can take out a negative 2 here. I can take out a x and a 3x and a 2. And so this is x minus 2 and 3x plus 2. Yes? So x is 2 and 2/3. And are all of these okay? It is negative 2/3. You are correct. Because the 2 gets moved to the right. That darn negative sign. How we doing? Does this make sense? But this is why we really have to be good at getting common denominators and recognizing what that common denominator is. Because we're trying to solve. No? Okay. All right, the last one is, can you read it to me, someone? So what do I really want to do to make this my life a little bit easier to see? I would put that 7 over 1 so that I'm looking at fractions across the board. And then what do I ask first? What am I asking? What can't it equal? What can't it equal? 2. Then what's my common denominator going to be? So I don't need the 1, right? I can just say x minus 2.
But at this point, like, since you know that 7's like just a number, can't you just subtract 10 over x minus 2 to the other side? And then work with it over there?
I guess.
5x minus 10 equals 7.
5x minus 10 over x minus 2 equals 7 over 1 and cross multiply? Sure. You can do it that way. You do it your way, and I'll do it my way, and we'll see if we get the same answer. So I'm going to take this and multiply it by x minus 2. And so I'll just get 5x is equal to 7 times x minus 2 plus 10. Yes? Y'all with me? So I got x's. We said x cannot equal 2. So that means there's no solution. Sometimes you'll get 2 and maybe one of them won't work because it'll be one of those values that we said couldn't exist. So these were pretty simple because I didn't factor your denominator. Your denominators were simple. You might have to factor your denominator to figure out what that common denominator is. And then do all the same steps that we did. You guys okay with this? Rachel, you want those list of words again? Okay, there you go. All right, so your homework is to finish your homework.